today we're going to take a look at a new way to solve systems of equations called elimination method. It's my favorite way just because it has a cool name, elimination. So we have two systems of equations here, which we can solve, we know, by graphing them. We also know by substitution we can solve it. And there's one last way called elimination. So elimination, the way it works is we are going to either add or we're going to subtract these two equations from each other to eliminate one of the variables. It's easy as that. So notice that both of these equations have a 5 here. One's positive and one's negative. So if we either add or subtract these equations, we can eliminate the y variable. In this case, if we add the two equations together, 5y plus negative 5y cancels out. It is eliminated. So if I add the rest of the equation together, 2x plus 3x, we get 5x. And over on the right side, we get a negative 10 if we add the two equations together. So we just eliminated a variable. Now this is a lot easier to solve. All we have to do is divide by 5, right? And we get x is equal to negative 2. We're almost done now. We have to get our y component as well. So to do that, we need to plug it into either the top equation or the bottom equation. I'm thinking that the top equation looks a little bit easier because it doesn't have a negative sign. So I'm going to take this x equals negative 2 and plug it right in for that x variable. So to do that, what it's going to look like then is we'll have 2 times, instead of x, a negative 2 plus 5y equals negative 24. Now, this is just our simple algebra solving for y. You guys should know the steps by now. So we'll add 4 to both sides. We get 5y equals 20. And we'll divide by 5 and get y, sorry, it's a negative 20, right? And we'll get y is equal to a negative 4. So these two equations do have a solution. They cross, if we were to graph them, at the point negative 2, negative 4. Alright, that's elimination method. Now you have to be saying, now Mr. Wilmus, why didn't you teach us that at the beginning? This is much easier. It can be a little bit more difficult. We're going to look at another problem here where it is a little more difficult. Remember we said before we want to either add or subtract the two equations from each other. Now the x's, I have a 2x and a 3x. Those are never going to eliminate if I add or subtract them. And the y's, I have a 7 and a 5. They're never going to eliminate either. So we have to do a little bit of math before we can eliminate them. Now what we need to do, it's similar to something you guys learned a long time ago with finding a common denominator. If we're going to add fractions, a 3 and a 4, we need to find a common denominator, right? Hopefully you're saying that, yeah, we do, and that common denominator is a 12. I can change this 3 into a 12 by multiplying it by 4, and this 4 into 12 by multiplying it by 3. So we're going to do the same thing here. We can either eliminate our x's or y's by changing the coefficient in front. I think the 2 and the 3 are going to be easier to change than the 7 or the 5. We're working with smaller numbers then. So to change this, the 2 and the 3 into something that is alike, like a least common denominator, we are going to have to change them to, hopefully you're saying 6. I can multiply 2 times 3 and equals 6, and I can multiply 3 times 2 and it equals 6. So I can't just go multiplying it by 3. We have rules in algebra. So I can multiply the whole equation by 3, both sides of the equation by 3. And if I do that, we haven't changed anything algebraically. Now on bottom, I'm going to multiply everything by a 2. So let's change these two equations around now. On top I get 6x plus 21y is equal to 12. On the bottom I get 6x plus 10y equals negative 10. Alright, so now I can add or subtract these two equations. We have a positive 6x and a positive 6x. So if I add these two equations together, I get 6x plus 6x, which is 12x. That doesn't eliminate. So in this case, we're going to have to subtract these two equations. So we'll subtract everything. We have 6x minus 6x eliminates. 21 minus 10 gives us 11y. And 12 minus 10 gives us 22. The negatives can be a little bit tricky. So sometimes it's helpful to write it out to the side. We have 12 minus negative 10. Minus and a negative changes to a positive, right? So 12 plus 10 is 22. That's where I got that from. And now we just divide by 11, and we get y is equal to 2. Now I need to plug this value in to either the top or bottom equation. Your choice, whichever one looks easier. I'm going to choose the top because it doesn't have any negatives. But either one will work for us. So I plug it into the top equation. 2x plus 7 times 2x plus 7 times 2 is equal to 4. We get 2x plus 14 equals 4. Now it's just simple algebra solving the equation. I'm going to subtract 14 on both sides. 2x is equal to a negative 10. Divide by 2. We get x is equal to negative 5. So this problem also has a solution, and it is at negative 5, positive 2. So if we were to graph these two lines, they would intersect at negative 5 and positive 2.